Up until now, all the programs we've looked at so far have used human user input from the keyboard. Now, most of those programs can be modified so that we could use input from a text file, and that's got tons of advantages, right? I mean, we can use larger text files, it's quicker to input, we can use the same test data over and over again without having to enter it every single time. Ultimately, being able to read information from text files and write it to text files is going to be an incredibly valuable skill to have. Lucky for us, the same scanner class that we've been using to take keyboard input can be used on text files as well. All that's different is that instead of opening it on the keyboard object, system.in, we'll open it on a file object. Making a new file object looks the same as making a new object of any other kind. We use the new keyword, we have the name of the class, and in this case, we pass one single parameter in. We pass a file name, which is the path name or the name of a file that we actually want to open. So in this case, you can take a look at this sample instantiation down here. We have scanner, reader. So we're making a scanner object, calling it reader, just as we have in the past. New scanner. Okay, there's our new keyword. And then here, instead of system.in, we're passing it a new file object. And in this case, we'll actually pass that new file object the file name numbers.txt. That means we want to open a file called numbers.txt, which by default is going to be in our working directory. We'll see exactly how to make that work in Eclipse once we start taking a look at some examples, but for now, just know that that means we want to put any text files we want to read in the same level as the SRC, the source folder, not in the SRC folder in your Eclipse project, but at the same level. The other easy way to do it is to just drag it into the Eclipse project when Eclipse is actually running. But again, we'll take a look at that a little bit later in this video. Now, at the end of every text file, there's a special character that marks the end of a file. It's not usually human readable, but essentially, if we're reading through a file automatically, and we get to that special character, we know we've reached the end of the file. So there's a method in the scanner class called hasNext, and hasNext watches for that special end of file character. Okay, as soon as we've hit the end of file character, hasNext returns false. Otherwise, it means that there's a next thing for this to read. It means we haven't reached the end of the file. So here, if you take a look at this example, we make a new scanner. We're looking at numbers.txt. That's the file we're opening. Okay, and we declare some doubles. We declare a double called number, sum, which we start off at 0, and an int called count, which we start at 0, while reader.hasNext. In other words, while we haven't yet reached the end of file character, we want to read the next double, add it to sum, and iterate our counter. So that happens as long as reader.hasNext returns true. In other words, as long as we haven't hit that end of file character. So when a Java program encounters an operation that it can't perform at runtime, the Java virtual machine does what we call throwing an exception. Okay, we've seen a couple of examples of this so far. One really important one that we talked about is when we try to divide an integer by 0. That's a runtime exception. Okay, but when we're working with files, there are a couple different things that could happen, right? A couple different operations that the Java virtual machine might not be able to handle. You know, one example is if the file is just missing, you know, when the program tries to open it. Or maybe the file's there, but its data is corrupted on whatever drive it's sitting on. So when these happen, I/O exception, input/output, an I/O exception is thrown. Now, I/O exceptions are usually pretty serious. So they're so serious, actually, that generally we call them a checked exception, which means the program has to at least acknowledge that we could throw an I/O exception. It's that serious. So that means if we're reading from a file or writing to a file, we have to make sure that we have acknowledged that we're watching out for an I/O exception. We'll talk more about how exactly to handle these a little bit later, but for now, what this means is that we have to add one simple phrase to the header of our main method in any program that's using text file input. And that phrase is throws I/O exception. All that means is what's going to happen is if a program actually runs into an I/O exception, the Java virtual machine is going to halt execution and throw that error message. So we can take a look real quick at an example program here. This program computes the average of a bunch of numbers that are sitting in a text file. Let's see. First, we have our import statement. We're bringing in java.io.star. Okay, that means there's a package called java.io, and the .star means give me everything in that package. Okay, so there are a bunch of different classes in that package. Give me all of them. That's what java.io.star means. And that's where we're going to get the file class and the IO exception class. We're also going to import scanner from java.util. Okay, so we can see we have our class compute average. There's a main method in there. It throws IO exception. Now this is important, right? We're reading from a text file here, so we have to make sure we have this line there at the very least. Okay, so we make a new scanner telling it what we're going to read from a file called numbers.txt. Just like we saw before, we're keeping a running sum and a running count of the numbers that we read in here. We're doing this loop as long as there's a next number. In other words, as long as we haven't hit that end of file special character. If there were no numbers, right, if count just stayed at 0 the whole time, we're going to print a message, the file had no numbers. Otherwise, we know that there was at least one number, and we'll print the average. The average of count numbers is sum divided by count. Okay, so that's reading from a file using a scanner object, and notable, it's throwing the IO exception, right? We have that line to check for the IO exception in case something goes wrong with reading in from this file. So that's if we want to read in from a file. If we want to write out to a file, we're going to use the printWriter class. Okay, and it includes two methods that should look pretty familiar to us, print and println. We've been using those not with printwriters, but to print to the console. When we use them with the printWriter class, those methods are defined for us to write out to an actual file. So declaring a printWriter object, again, looks a lot like declaring a scanner and instantiating a scanner. So printWriter writer equals new printWriter. We'll pass it a file, and inside that file, we'll pass a file name. Okay. Now, this is important. When we're done actually writing to the file, we have to remember to close the file. If you don't close the file, you might lose all the data. It might not get saved to the file that you were trying to write to. And one more time, when we use a printWriter, printwriters can also throw input-output exceptions, so we have to include that phrase, throws IO exception, with our main method. So another quick example, filter zeros. Here, again, we're bringing in java.io.star, bringing in scanner. This program takes as an input a file of integers, and it's going to write whatever those integers are to an output file, except it's going to filter out any zeros. Okay, so we'll see how this runs in just a second. But let's go through the code first. We have our main method. Again, we have throws IO exception because we're reading and writing files. So first things first, we open our reader and our writer. You can see we have numbers.txt and new numbers.txt. As long as there is a next line to read in our input file, we will read the next int, store that in number, and if number is not equal to 0, we'll write it out. Okay, and again, we're using our writer object here that we declared before, and we're writing it on its own line. So we'll write the number and then go to the next line. That's what the println method does. Finally, at the end, we have to remember to close our writer. Okay, so let's take a look at the programs we looked at in the lecture slides. First, let's look at compute average. The code's exactly the same. I'm running this on a file called numbers2.txt, and we can see I actually don't have that file anywhere here. So in order to be able to refer to this file without any kind of file path like c/mydocument/user/whatever, in order to just be able to refer to it as this, what I have to do is take the location of that actual text file, wherever I have it on my drive, and I'm just going to click and drag it into this project. I'll copy it, and we can see now it shows up here. It's at the same level of source. It's not inside source. Okay, and actually, if we were to scroll into my workspace, which we can see is right here, let's go into Unit 1, Lectures. We can see I have my source code. Numbers 2 now shows up right here. Okay. So if I run this, first I want to take a look at what's inside here. Looks like I've got a series of double values, 34.6, 22.33, 66.75, and so on. Great. So I'm going to read each of those values until there are none left, and I'll calculate a running average just because this file is not empty. So let's run it, make sure it does what we expect. Beautiful. The average of 6 numbers is 53.54. Fantastic. So let's take a look at filterzeros.txt. Filterzeros.txt, if you remember, it reads in a series of ints from numbers.txt, and if the value is not 0, then it's going to write that out to a file and print it out to the console. It's going to do both. Okay, we have both of those statements here, and they're separate, distinct statements. So I've actually already brought the input file into this Eclipse project, and we can see we have 8 numbers, 2 of which are zeros. So we expect 6 numbers to make it out. Okay, 6 numbers to be printed to the console and to be written out to the file new numbers.txt. So let's run that real quick. We can see of those 8 files, yup, the zeros got filtered out, and we open up new numbers.txt. Beautiful, no zeros in there. Take a second, run these on your computer, play around a little bit if you'd like. Now, before you close up shop for the day, here's what you want to make sure you can handle. You want to know what exactly this line of code does and how you can, in your own code, declare and instantiate a scanner object that can read from a file and a print writer object that can write to a file. Sit down and think about how you could write a code segment that uses loops to read integers from a file and just display them straight to the console window. Okay, nothing complicated, just read from a file and print directly to the console. And as a third challenge, think about writing a code segment that assumes that a file has an even number of integers. Okay, read those values in pairs and then display the larger one of each of the two in the console window. So for every 2 numbers, print the larger of the 2 numbers.